Hey, what's going on everybody? It's Tony with Red Cyber Dragon. This video is a stream I did a few days ago of a Godot tutorial. Basically, I'm making a game from a book called Space Rocks. I'll make sure to link the book in the description. Make sure you check it out. Thanks for watching. So, here's what I want to do. I am going to show you a completed project, mostly complete, project, to show you what the end state of this new project should look like. Basically, I followed a tutorial and made this Space Rocks game. And now I'm going to try to recreate it. Alright, so let me show you. So basically, it's your basic, Space Rocks. It's also up on itch. It's got music. You shoot the rocks. What happened? Oh, that's a break. Random break point. That wasn't anything wrong with the program. It's just there's just a breakpoint in the code, so it stopped. Anyways, you can see it keeps score. It doesn't like having user information. It'd be cool to implement like a scoreboard. Oh, you can see it's got particles for the exhaust, and you can see it goes around to the other side of the screen. Yeah. It reminds me a lot of the StarCraft. I mean, not the whole game, just the ship. And you need to get rid of all the rocks to get to the new level. So this is this. I think the rocks might be moving faster. That's also not supposed to happen, but I actually kind of like it, so I'm gonna leave it in there. I like that it comes out and starts shooting at you. And it's still there for the first game. Yeah, that's probably it. Didn't like that. Oh, and you have 3 lives. I mean, if I'm being honest, it's not that fun. It's just kind of... So yeah, that's the plan. The plan is to recreate that, looking at the text as little as possible. And obviously, I'm not going to show you guys the text because it's a book I paid for, but I will obviously shout out the author when I put this on YouTube. So, it's called like Godot 4 Projects. If you just look that up, you'll find the book for sure. All right, let's give this a shot. So we'll go Godot, new project, and we'll go Space Boulders. Yeah, let's go with Space Folders. Okay, we click create folder, so it creates a new directory. We'll use forward plus. That's fine. Forward plus. We'll use git. Okay, cool. So first thing we need to do, this is going to be hard to do without the text. But okay, first thing we need to do is we need to grab the assets. So if we go... Oh, my kid is yelling upstairs. He's crazy. Let's do some... Okay, so go here, grab the assets. Actually, you know what? I already have the assets. Up one. Okay, cool. So now we got our assets in here, and assets just means, you know, like pictures and animations and things like that. See, this is going to be our spaceship. The play button, a shield in the background. Okay, so this is going to be a 2D game. And let's see here. I think we create the player. We should create the player scene first. Or maybe the back main has the background, right? Yeah, but let's we'll start with the player scene. Okay, so for player, is a rigid body 2D. Okay, so we go to create. Wow, this music is dark. Okay, rigid body 2D. We're gonna add a sprite. A 2D sprite. And sprite, again, is just like a picture. And a collision shape. A collision shape basically tells the game that this is a solid object. Oh my god. My kid, you can't hear it, but my kid is screaming like a freaking banshee upstairs. Okay, so let's add player ship to the sprite. So we'll click on the sprite up here and then... Okay, and then put in player ship under texture. Okay, and now we see it. We can use the hand tool and zoom in. So we want actually the scale to be half, because we don't want it to be too big. And then rotation should be 90 degrees. And I'm just gonna check that with the other code here. Yeah, 90 degrees, 0.5. Okay, cool. And then, so then the collision shape, again, this is what makes it a solid object. We're gonna click on new circle shape, and then we're gonna go over here and we're gonna size it, I think. I'll unclick the hand tool. Use this. And click the little red circle here and pull it out until it kind of like has got the most of it in there. You don't want to make it like bigger, you want to make sure it's like almost the same size. A little smaller is okay, in my opinion, but bigger would be bad for the player, because then the player doesn't know why they're colliding with things when they're not actually touching them. Just an opinion. Okay. Okay, also I see in here we need a muzzle, which I guess is for shooting. And then I think that's it for now. So we're gonna add another node here. A muzzle. Oh no, it's a marker. Marker 2D. And we're gonna name that muzzle. Let's see here. The muzzle should be in the front there. I'm gonna put it in the front right here. Alright, so we'll save this, and we'll call it player. So this is called a scene. Several scenes will make up your game, basically. I guess a scene is like an object, and then like it's got sub-objects. They're all called nodes, I think. So you have a root node here, which is the rigid body, which is just like a thing, I guess. Okay. Now what? I'm gonna have to reference the text simply because the order of which we do things matters. I think the next thing we need to do, yeah, I need to reference the text. I'm not gonna like read it out, but just like the order of things. And I'm not gonna show it on screen. Where the hell is it? I named it Godot Book. Godot Book. Okay, so we create the body and the physics. Cool. Okay, so now we're gonna work on the script for the player. What was this thing? Project settings, textures. Oh, okay, this is how we smooth out textures. Okay, so we'll go into project settings and go to textures, and then default texture filter we'll set to nearest. Okay, yeah, see, that makes it look so much better. Did you see that? If we go to hide this, we go to project settings and change that back to linear. You see that? It's all like blurry. But if we hit nearest, then it becomes much sharper. Object. Okay, so now we're gonna attach a script. We'll just leave it as player GD. It's this little button up here. Player.gd, hit create. So this is the default script. And essentially, we need to start like it's called a finite state machine. It kind of looks to me like it's a while loop, sorta. Basically, it's got these conditions, and depending on the condition, certain things happen, and it goes in a loop until you basically end the program. And that's going to be in our player node. And we're using GD script. Godot also has C# available. I know some C#, but I don't know any Godot related C#. So we're going with GD script, which is a lot like Python. Reminds me of Python. I'm mostly a Python developer, and this language feels pretty comfortable for me. So, all right, first we're gonna create enumeration. All right, so we're gonna type enum, curly brackets, and then we're gonna type in the states that we want our player to have. So init, which is the initial state, alive, which is when the player is alive and playing, invulnerable, which means the player can't be killed, and then dead. Okay, and then var state, which is what state is the player in. The default is going to be init. Okay, makes sense? All right. And now we go ahead and number. Okay, no, that's what this does. So this, like I said, it creates a numbered list. So if we call one, then it's the same as calling init. Init equals 1. Alive equals 2. Vulnerable equals 3. Dead equals 4. Or no, sorry, 0, 1, 2, 3. We're just declaring these constants in numerical order, basically. It'd be the same as if we'd said constant init equals 0. Constant alive equals 1. Okay, so now we're gonna create. So this function ready runs every time the scene starts for the first time. And when the scene starts, we want to change state to alive. Now, what does that mean? Well, it's a function we haven't created yet. We need to create the function. So function, func, change state, and that's going to take in the parameter new state. And then match new state. And then each condition. So init, this is basically saying if the state is init, then collision shape 2D dot set deferred disabled true. Now, let me look what the heck this means. Yeah, this just means turning on. This is one thing I don't like about this engine is I feel like GDScript is overly verbose. Like, why can't this just be collision shape 2D dot disabled or dot disable or something like that? I don't know. But this just means, as far as I can tell, this just means you're turning off the collision. So in the initial state, it can't be collided with. And then in the alive state, we're going to set it to disabled false, which means it can be collided with. And then in vulnerable, it'll be true, and then dead, it'll be true. So for instance, alive, collision shape 2D dot set deferred disabled false. Because when we're alive, we want the ship to be able to be hit, the player to be able to be hit by stuff. Okay, and then in vulnerable, collision shape 2D dot set deferred disabled true. I mean, the other thing, well, because we're gonna add to this, I was gonna just be like, if not alive, then it's true. Like, but this is just the initial kind of, it's not really a loop, it's sort of a switch statement, I guess. Okay, let's continue. So invulnerable, you won't be able to hit it, and then dead. Same thing. I'll just copy it. Okay. And then we want to set state to new state. All right, so now we're gonna add control of the ship. So we'll go, we need 2 variables. No, sorry. 4 variables. 2 exported. So we'll add our exported variables up here. Export var engine power. By the way, I am not an expert in this engine. Obviously, I am learning from this, so I am doing my best to explain what I think is going on. But I am by no means an expert in this engine. We are learning together. Spin power equals 8,000. Now, I don't... Okay, that controls how fast the ship can accelerate, and thrust represents the force being applied to the engine. And rotation represents which direction the ship is turning. So you can apply torque or rotational force. Okay. Var thrust equals vector2 dot 0. Var rotation direction equals 0. Okay, so it says linear damp. Set this to 1, and angular damp. Set it to 5. I think we also need to set up controls. So we go here. Input map. Project settings. Physics. 2D. And we want to. Let's just look at the other code. Can I just copy these? That'd be interesting. Okay. Anyways. All right, A. Oh no, sorry. Rotate rotate left, and then we'll add an input for that. And it'll be A, right? Okay. And we'll add another one, and it'll be the left arrow. Okay. Now let's add another one for rotate right. And that will be D. Oh, D. Okay. And right arrow. Okay. Thrust. Up or W. W. Okay. Up. Okay. And shoot will be spacebar. Also, mouse button. That's not something I had on the other one, but I feel like that's an improvement. Cool. So now we got our controls set up. Now, if we go to what else? I want to get like a minimum viable thing to show you. Alright, we did that. Okay, so now we're going to add... Okay, so now we're going to connect those controls in the code so that the player does stuff. So this function right here called process, that runs every frame. Or, yeah, it runs every frame. So actually, the faster your frame rate, the faster it's going to move. We'll fix that. Using the delta. All right, so every time process runs, we want to run get input. And that's getting input from the user. So thrust the player. So we'll make that function, func, get input. And then, yeah. Thrust equals vector 2.0. And then we're going to say if, that just means it's not going to move, right? I think that's what that means. If state in dead init return, okay? If state in dead or init don't do anything. So basically this means don't listen to what the player says if the player is dead or the game hasn't started yet. Make sense? And then if input dot is action pressed. Ugh, that is so irritating. Why not input dot pressed? Like, that is annoying. Thrust. Thirst. Thrust, right? The action that we defined earlier. Then thrust equals transform x dot x times engine power. Oops. Okay. And rotation direction is equal to input dot get axis, rotate left, rotate right. We're going to add another function here called physics process, func underscore physics process delta. Okay, and this is what actually moves the object. I think this is a built-in function that will actually affect the object. So when you call this, you hit constant force. See, it's already predefined. Equals thrust. And that tells the engine how fast to push the thing, I guess. Constant torque equals rotation direction times spin power. That makes sense, right? This is a really good way to learn it. I know there's like almost nobody here, and hopefully more people will watch the YouTube, but this is a really good way to learn it because I am saying everything that I am doing and understanding it much more than if I'm distracted by YouTube videos while reading this book, which is what I did the first time. I can tell you what each line of this code does in a way that I don't think I could when I was just doing this on my own. So, just a tip. I just perform better for an audience, I guess. That's just how I am. Even if it's an audience that I've imagined in my mind, you know, I just perform better in front of an audience. Anyways, let's keep going. I'm pumped. Let's do it. Okay, screen wrap. If the player goes off one side of the screen, they should appear on the other side. I mentioned that earlier. Oh, well, actually, okay, so we should be able to fly around now. No main scene has ever been defined. Select one. You can change it later in project setting. Okay, we'll select the current. This is not going to be the main scene, but we'll select the current one just so we can fly around. Okay, so we have a problem here. It's the gravity? Gravity should be 0. All right, let's try again. Okay. Damp. Let's look in the old code and see what's different here. Damp. 1 and 5. Combine. What is gravity? Gravity scale's still 1. Okay. Okay, good. Okay, we can see. All right, cool. That's awesome, right? See, we can stop. We can move forward. We don't move backward. Ah, shit. Maybe we can get back. Oh, no, we can't because it doesn't move backwards. Oh, wait, there it is. Okay. Duh, because I rotated it. Stupid. Okay. You can see, like, you move forward and I let go. This keeps going a little bit. Doesn't immediately stop. Turn around. Go this way. Okay. But we do need screen wrap now. Because if I go off the page and I don't see myself, I'm kind of fucked, right? So let's do that. Let's do that, and then I'm gonna break for lunch, and then maybe I'll hop back on and do this some more. This is fun, and it's definitely a way more effective way of learning this, even if, like, I don't give a fuck. Even if no one is watching. Like, it does not matter. I am learning a ton right now. Just by streaming what I'm doing. So, highly recommended. Alright, let's do screen wrap, because it feels unfinished. Okay. So we're going to set a new variable called screen size. Var screen size equals get viewport rect dot size. That is, I'm sorry, like I didn't, again, I'm noticing more because I'm streaming this, but that is such an irritating way to name that. I'm sorry, it just is. Like, screen size equals get viewport rectangle. What? Why is it not just screen size? I don't understand. That's silly. Okay. In fact, it's so silly. I'm sorry, that's setting the screen size command. Control X. So we run that when we start this. So add this to ready. We create the variable up here. Sorry, vector. Don't ask me what a vector is, we'll look it up later. Vector. Wait, vector dot 0. Or is it vector 1? Actually, it might be vector 2. I think it's vector 2. I think they renamed something after the thing. Let's check the old code. Screen size vector 2.0. Yeah, okay. All right, so Wherever this book says vector, it actually needs to be vector 2. I'm sure that's an update. Okay. So that gives us the screen size, passes it here. And then in physics process, we need to add several statements. So if position dot x is greater than screen size dot x, okay, so that means if it's past the right side of the screen, I think, then position dot x equals 0. Right? That makes sense. In fact, let's test it right now. That means if I go off the right side of the screen, it's going to put me onto the left side of the screen. Okay, now I'm confused. Is it supposed to be 0? There we go. I don't know. What the heck did I do? If we take that out, does it work? I wonder. Yeah. Okay, so maybe I wonder if we do, now I'm just fucking around, but if I just put up here position dot x equals 1. What does that do? Nothing? Okay, nothing. Okay, the reason it won't let me move from there, I'm just realizing now, is because the only thing we put in here is that if position.x is greater than screen size.x, then position.x equals 0. I think it's because we only have one if statement there. If position dot x is less than 0, position dot x equals screen size dot x. Let's try that. If position dot y is greater than screen size dot y, position dot y equals 0. All right, okay. And then we'll just copy this. And then just change this to y. Probably a more memory efficient way of doing this. Okay, also it's not working. We must be missing something. Okay. Var screen size vector dot 0. Screen size equals viewport. Oh, here. There we go. Alright. So, yeah, only put the var there when you're declaring a new variable. So if I go past here, it should show me up there, okay? But now it's not letting me move from here. Okay, now it's showing up there, and now it's not letting me move from here. So it sticks me here and keeps me there. Oh, I'm sorry. This isn't the actual code. This is just to, okay, so this is the way you wouldn't do it. So I apologize. Let's look at the other code. What did we do here? We use integrate forces. Now that makes it a little hard to understand. But let's type it out. So we're gonna delete this. So apparently that won't work. Apparently you're supposed to use integrate forces rather than physics process if you are trying to affect the body's state. That's just what it says. And okay, so we're going to use wrap F, which takes the min-max. Okay, so we're going to be using the min-max, and then using transform to transform the actual object, I think. So let's write this out. Func integrate forces. We're going to use this instead of physics process to directly affect the body. Integrate forces. Okay, so var x form equals physics state dot transform. Okay. Where is physics state? Oh, do we change this to player state? Oh. Note that you're using physics state for the parameter rather than the default state. Just to avoid confusion, this is already being used to track the player's state. Physics state. Oh. Got it. Got it. We're just changing the input. We're just changing the input parameter. It's fine. Var xform equals physics state dot transform. Xform equals physics state. Oh no, sorry, we already did that. Xform dot origin dot x. Okay, so that's the x position equals wrap f, and that takes in a value, a min, and a max. So x form dot origin. So what do we want to transform? Dot x, and then between 0 and the max of screen size dot x. Okay, that makes sense, right? So it's saying that we want to do a wrap if the origin dot, or we want to put the object on the x-axis. We want to put the object at 0 if it exceeds the screen size, right? And so if we just leave that and we do physics dot transform, so physics state dot transform equals xform. That should do it on the x-axis. So let's hope that's correct. If I'm correct, this will wrap it on the x-axis. Boom. Now, y is a different story, because we haven't done that yet. But let's see. Where does it come out? Okay. A little strange, but yeah. So now we just need to do the same for y. Xform. We'll just copy it and change xform.origin.y, meaning where the object is on the y-axis. Set that to to 0 if it exceeds the screen size. And up and down. Yep, okay, there we go. Why does it take so long? That's weird. It shouldn't really take that long, right? Did I miss something? Okay, well, it is working. That is what we were supposed to do. Oh no, I see. I see the problem. There we go. Okay, so the problem was I was setting the max to the screen size.x, which is bigger than the screen size.y. But now we got it, right? Okay, so if it exceeds the max of screen size.y, it's going to set it back to 0. What do I set? Or what am I looking at? What's the minimum and what's the maximum? So if it's the maximum, I'm going to set it to the minimum. If it's the minimum, I'll set it to the maximum. Make sense? It looks like a lot of this stuff is already predefined, though poorly named. Just going to say that. All right. So I think this was pretty successful. Next time we'll work on shooting. I'll probably do that later today. I think tonight I will stream again, and we will work on making it shoot. Sound good? And maybe we'll swap out the assets. I got some dragons. Some dragon assets that I want to try. I want to try using my own for the animations and shit like that. So we'll give that a shot. All right. But thank you for joining me. This has been Red Cyber Dragon broadcast. My name is Tony. Thank you again for coming, and we will see you next time. All right. See you later.